Vacuum evaporation represents a more recent innovation in salt production. This method utilizes a closed system and reduced pressure to lower the boiling point of water, enabling faster and more efficient evaporation. Vacuum evaporation is particularly suitable for regions with limited sunshine or colder climates. In this,
we are looking at the production of salt. Have you ever imagined the salt you see on your dining table? Where does it come from? We are going to take you through the journey of salt from the sea to the dining table where you consume that salt. Kindly watch this video up to the end, but before that, kindly subscribe if it's your first time, and then like this video.
Salt, a seemingly simple compound, has played a pivotal role in shaping human civilization. Its distinctive salty taste is something we are all familiar with, but beyond its culinary uses, salt has been a cornerstone of economies, a symbol of power, and a vital element for human survival. From ancient times to the modern era, salt has left an indelible mark on our world. Salt's importance stems from its ability to preserve food. Before refrigeration, salt was the primary means of preventing spoilage. This preservation power enabled long voyages, sustained armies, and facilitated trade across vast distances. Societies throughout history have recognized the value of salt, often placing it at the center of their economic and social structures. Salt's historical significance is deeply intertwined with the rise and fall of empires. The control of salt routes and production sites often determined economic dominance and political power. The ancient Romans, for example, paid their soldiers in salt, a practice that gave rise to the word salary. In medieval Europe, salt was a precious commodity, heavily taxed and fiercely fought over. The salt trade routes crisscrossed the continent, connecting distant lands and cultures. The wealth generated from salt financed grand cathedrals, funded wars, and fueled the growth of cities. Solar evaporation, a centuries-old method, remains one of the most prevalent ways to produce salt. This natural process utilizes the sun's energy to evaporate seawater or brine, leaving behind salt crystals. Coastal regions with ample sunshine and low rainfall are ideal locations for solar evaporation. The process begins by channeling seawater or brine into shallow, interconnected ponds. As the sun heats the water, it gradually evaporates, increasing the salt concentration. Over time, the salt reaches its saturation point and begins to crystallize on the pond's floor. These crystals are then collected, washed, and further processed, depending on their intended use. The legacy of solar evaporation can be witnessed in ancient salt works scattered across the globe. These historical sites provide a glimpse into the ingenuity and resourcefulness of past civilizations. From the terraced salt pans of Maras in Peru to the ancient salt mines of Hallstatt in Austria, these sites stand as testaments to the enduring importance of salt. These ancient salt works often employed simple yet effective techniques to maximize salt production. The design of the ponds, the control of water flow, and the timing of harvests were all carefully considered. The knowledge and skills passed down through generations ensured a sustainable and reliable source of salt for centuries. Section 5. Mining salt, delving into the Earth's depths. While solar evaporation relies on surface water, mining extracts salt from underground deposits. These deposits, formed over millions of years from evaporated ancient seas, are accessed through deep shafts and tunnels. Salt mining is a more complex and capital-intensive method compared to solar evaporation. Miners use heavy machinery to drill, blast, and transport the salt from deep underground. The extracted salt is then crushed, purified, and processed into various forms. Salt mines are often vast and labyrinthine, with some extending hundreds of meters below the surface. Working conditions in salt mines can be challenging, requiring specialized equipment and safety measures. Section 6. Vacuum evaporation. Modern advancements in salt production. Vacuum evaporation represents a more recent innovation in salt production. This method utilizes a closed system and reduced pressure to lower the boiling point of water, enabling faster and more efficient evaporation. Vacuum evaporation is particularly suitable for regions with limited sunshine or colder climates. In this process, brine is heated in a vacuum chamber. The reduced pressure allows the water to evaporate at a lower temperature, significantly reducing energy consumption. The evaporated water is then condensed and reused, making vacuum evaporation a more environmentally friendly option compared to traditional methods. Section 7, Environmental Impacts of Salt Production. While salt production is essential, it is not without environmental impacts. Solar evaporation ponds can alter coastal ecosystems, impacting local flora and fauna. Mining operations can lead to habitat disruption, soil erosion, and water pollution. Responsible salt production requires careful planning and mitigation measures to minimize environmental harm. This includes proper site selection, wastewater treatment, and land reclamation efforts. Additionally, exploring sustainable practices like using renewable energy sources and reducing water consumption is crucial for minimizing the ecological footprint of salt production. Section 8. Modern applications of salt beyond the dinner table. While salt's role as a food preservative and flavor enhancer remains crucial, its applications extend far beyond the culinary realm. Salt is a vital component in various industries, including chemical manufacturing, road de-icing, water treatment, and even the production of textiles and paper. In the chemical industry, salt serves as a raw material for producing chlorine, caustic soda, and other essential chemicals. Road salt helps melt ice and snow, ensuring safer winter transportation. Water softeners utilize salt to remove mineral deposits, improving water quality. Salt's versatility and wide-ranging applications highlight its continued importance in the modern world. Section 9, Conclusion: Salt, a timeless and essential resource. From the ancient salt routes to modern industrial applications, salt has shaped human civilization and continues to play a vital role in our lives. Understanding the various methods of salt production, their historical context, and their environmental impacts is essential for appreciating the significance of this seemingly simple yet indispensable compound. As we move forward, it is crucial to balance the growing demand for salt with sustainable production practices that minimize environmental harm. By embracing innovation, promoting responsible sourcing, and appreciating the intricate journey of salt from sea to table, we can ensure a sustainable future for this timeless and essential resource.